Hello, and welcome to a tutorial on how to use the SPEKTR tuner. A problem that many SPEKTR users face is modeling the spectral characteristics of a particular X-ray tube. To demonstrate this problem, exposure measurements were taken and compared to the exposure of a spectrum generated by SPEKTR at the same tube potential, MAS, source to detector distance, and added filtration as the physical exposure measurements. Running this, we see that there is a large percent difference between the measured and the simulated exposure. SPEKTR Tuner was created to allow users to model the spectral characteristics of particular X-ray tubes by outputting the added filtration in terms of thickness of aluminum and tungsten that minimizes either the exposure or air chroma difference between the measured and simulated spectra. This tool can be demonstrated using previously collected MAS, source to detector distance, and exposure measurements. SPEKTR Tuner's first argument is an input spectrum generated at the same tube potential as the beam to be simulated. The MAS and measurement arguments are single column vectors such that the MAS and its corresponding exposure or air chroma measurement are recorded within the same row. The MAS argument is in units of milliamp seconds, and the measurement argument is in units of either millirankin or milligray, depending on if exposure or air chroma is measured. The source to detector distance, measured in millimeters, is used to scale the MAS measurements to 1000 millimeters, which is the source to detector distance of all of SPEKTR's outputs. The added filtration argument represents the added filtration within the measured beam. This argument accepts an n by 2 vector in the same format as the other filtration functions within SPEKTR. The measurement flag is used to denote the type of measurement contained in the measurement argument. It accepts either exposure or air chroma as a string. There is also an optional parameter that allows the user to estimate the thickness of aluminum and tungsten to equate the measured and simulated exposure or air chroma. It acts as an initialization for the algorithm underlying SPEKTR Tuner. Let's run this function. After approximately 30 seconds, SPEKTR Tuner outputs the thickness of aluminum and tungsten necessary to match the exposure between a simulated and measured spectrum. To validate this, we will apply the filtration outputted from SPEKTR Tuner to the simulated spectrum and compare its exposure to our actual exposure. Running this, we can see how our filtration changed our spectrum from the blue line to the red line. Comparing the exposures, we see that they are more similar now. Thank you for watching this tutorial, and I hope that it was helpful and informative to you.